Hello students, welcome to my channel Shaik's Eduworld. So today we are going to discuss real numbers exercise 1.1. So ఎవరైనా బిఫోర్ వీడియో మిస్ అయితే ఇంట్రడక్షన్ అది కంపల్సరీ చూడండి. సో అది చాలా ఇంపార్టెంట్. ఓకే, లెట్స్ స్టార్ట్ విత్ ఫస్ట్ వన్. ఎక్స్ప్రెస్ ఈచ్ నెంబర్ యాజ్ ఎ ప్రోడక్ట్ ఆఫ్ ప్రైమ్ ఫ్యాక్టర్స్. ఓకే, 140కి ప్రైమ్ ఫ్యాక్టర్స్ రాయాలన్నమాట. సో ఫస్ట్ ఆఫ్ ఆల్ విల్ రైట్ ఆల్ ద prime numbers that we know from 2 to around how many ever you know. First we will make a note of it. So 2, 3, 5, 7, 11, 13 and so on. So we need to know the divisibility rules also. So this number is ending with 0, so it will be divisible by 2 and 5. So first of all we divide with 2. So 2 70s are 140. Again it is ending with 0, so again we will go with 2. 2 times 35 is 70. Now it is ending with 5, so divisibility rule of 5 will be, if any number is ending with 5, so it will be divisible by 5. So we divide with 5. So 5 7s are 35. Now 7 is a prime number, right? So once you got the prime number at the last, we'll stop the process. Now we will write 140 as a product of these primes. So 2 came 2 times, so 2 square times. 5 came only 1 time, so 5 times. 7 came only 1, so 7. Even you can keep the powers for 5 and 7 as 1 and 1. So it's not necessary. So this is the way that we will write 140 as a prime factors. Now let's do number 2. Number 2, 156. See, this is an even number because it is ending with 6. Now even number is divisible by 2 always, so we'll divide 156 by 2, so you get 78. Again it is ending with 8, so it's a even number. Even number again divisible by 2, so 2 3s are 6, 2 9s are 18, so 39. Now 39, so 39 is divisible by 3 because this is a simple one, so 3 1s and 3 3s. Now 13 is a prime number in our list, so I told you we can stop here, or you can write 13 1s are 13. Now we will represent 156 as 2 came 2 times, so 2 square times 3 times 13. So this is the way that we represent 156 as a prime factors. Now let's do number 3. It is 3825. So see, it is ending with digit 5, so it is divisible by 5. So you can divide this by 5. 5 7s 35, so 32, 5 6 are 30, and remaining 2 25, so 5 5s are 25. Even if you don't know like this, you can divide it. Okay, so this is a normal division. 5 7s 35, subtract it, you will get 3, bring down 2. Now we have 32, 5 6 are 30. Subtract, you get 2, bring down 5, so 5 5s are 25. Okay, so either way is easy for you, that you can do it. So if you have large numbers, better we go a normal division. Okay, now see, this is again ending with 5, so again we are going to divide it by 5. So 5 1s are 5, 5 5s are 25, and 5 3s are 15. Still, if you don't know how can we do this, so you can go same division method again. Even if you divide 765 by 5, see, 5 1s are 5, subtract it, you get 2, bring down 6, 5 5s are 25. Again subtract it, you get 1, and bring down that 5, so 5 3s 15. Okay, so to learn math you need to know at least first 15 tables. This is mandatory. So we got 153 now. Again, see 15 and 3 is divisible by 3, so we will go with the 3 table this time. So 3 5s 15, 3 1s 3. Now again 51 will be divided by 3 because 5 plus 1 is 6, right? So 6 divided by 3, so it will go in 3 tables. So 3 17s are 51. Now 17 is a prime number, so we are going to stop here. Okay. Now let's write this 3825 in prime factorization. So 5 came 2 times, 3 came 2 times, and 17 1 time. So we'll write in ascending order. So 3 square times 5 square times 17. Let's do number 4 this time. It's 5005. So 5005 again ending with 5. So obviously it is divided by 5. Now we are going to divide it by 5. So 5 times 1 is 5, 0, 0 and 1. This is simple division. Now this is divisible by 11. You can check it. So 11 9s 99, remainder 1. So 11, 11 ones are 11. You got 91, right? So 91 is divided by 13. So 13 sevens are 91. At least you need to know first 15 tables, guys, so that it will be easy for you. So 7 is a prime number, so we can stop and we'll write 5005 as product in ascending order. So 5 times, so the prime number next is 7, the next least, then we have 11 times 13. Okay, remember we need to write in ascending order. Either you can keep the powers 1 or you can leave as is. You need to know the prime numbers between 1 to 100 and first 15 tables to do this. This is the prerequisite. Next one, so 7429. 7429. This is not an even number, so it will not divisible by 2. Sum of digits in the number, it is not divisible by 3. It is not even divisible by 5. 11, 7, 13. So what I will do is I will try with 17. 17, if I divide 17 for the 68, so 62, 17 3s are 51, and then 17 7s are 119. You can divide beside it. Again, it will be divisible by 19. Next prime number, 19 2s are 38, remainder 5, 57. So 19 3s are 57. We got 23. 23 is a prime number. So I'll stop the process and we'll write the product. That is 17 times 19 times 23. It's optional to put the powers. Okay. So this is very easy one. Now let's do the second problem. Find the LCM HCF of the following pairs of integers. Pair means 2, right? So we have to verify LCM times HCF equals to product of the two numbers. The given numbers are 26 and 91. So let me write 26 and 91 here. 26, 91. And then now I'll write factors of 26. So let us write that into prime factors. 26 is 2 times 13. Same way 91. If I do it, I'll get 7 times 13. You can do it beside. Now to find the LCM, take the non-common factors, that is 2 and 7. These two are non-common in both, and 13 is the common factor in both numbers, right? So to find LCM, what I will do is I will write the non-common factors first, then I will write the common factor 13. So we'll write all the factors first. So 2 and 7 are non-common in both. So I will take the powers as is. So 2 power 1, 7 power 1. Then 13 is the common factor. We have to take the highest power in this common factor. The common factor is 13 and its highest power is 1, right? Both have power 1, so the highest power is 1. So if I multiply all three together, I'll get 182. This is the LCM. Now to find the HCF, what we do is we take only the common factor. Okay, we have to ignore the non-common factor. So common factor is 13, so I'll take that. And the power should be the minimum means 1 and 1, right? The minimum is 1, so I'll keep it 1. So HCF is 13. Now let's do LCM times HCF, that is 182 times 13 will give me, so 2366. Now let's check the product. Product means we have to multiply the numbers. 26 times 91, if you do that, 2366. That means we just verified that the LCM and HCF product of any two numbers is equal to their product. Okay, so LCM HCF of any two numbers equals to the product of the two numbers, right? Hence it is proved. Number 2, another pair of numbers is 510 and 92. So 510, let's write that into prime factors. You need to do side here. So it is ending with 0, so it is divisible by 2, so 255. Ending with 5, I'll divide with 5, so I'll get 51. Now 51 is divisible by 3, so 3 17s are 51. Now 17 is a prime number, we stop here. Now let me write all the prime factors in a ascending order. Okay, 2 times 3 times 5 times 17. I will write 3 again, it's not visible. Okay, so all the powers are 1, I'll keep the powers 1. Now let's write 92 as a prime factors. Even number divisible by 2, 2 times 46, again 46 is a even number divisible by 2, so 2 times 23. 23 is a prime number, we stop here. Now 2 came 2 times, so 2 square times 23. Now let me write LCM as we discussed. First we'll write all the factors and then the common factor is 2 here. So I'll write all the numbers first. After writing all the prime numbers, now let's check the powers. Now see, 2 is a common factor, so the highest power for 2, since we are doing LCM, we took the highest power, 1 and 2, the highest is 2, so I'll take 2, and remaining all prime numbers are not common, so I'll put the power as it is, like 1 1 1 1. Okay, now let's multiply to get the LCM. Once you multiply, you will get 23,460. Now let's find the HCF. HCF means the lowest power of the common factor. The common factor is 2 here and 510 and 2 square here. Alright, so we have to take the least power. Least power is 1, so 2 power 1, that is 2. So this is your HCF. Now let's check the LCM times the HCF is 23,460 times 2. So if you multiply this, you will get 46,920. Now let's multiply the numbers, given number, that is product. Product is 510 times 92. So if I multiply even, I am getting 46,920. So the product of the two numbers is equal to product of their LCM and HCF. So hence it is clear. Alright, let's do number 3. That is, the given numbers are 336 and 54. So let's do prime factorization for 336, right? So it is an even number, so it is divisible by 2. So 168 it will go. Again 2 times 84 is 68, again 2, because all are even numbers. So 42, again even number. So 2 times 21, and this is so simple, it will go in 3, so 3 sevens are 21. So we are ending with prime number. I am going to write 336 as 2 power, how many times it is came guys? 4 times. So 2 power 4 times 3 came only once, 7 came only once. Now let's do for 54, it will go with the 2 27s, and then 3 table, 3 nines, and then 3 3's 9. So 3 is a prime number, we'll stop here, and then we'll write 54 as 2 power 1, because only one time, times 3 power 3, it is 3 times. Now let's do the LCM first. LCM means we need to take the highest power in common factors. We have common factors 2 and 3 in both given numbers. So 2 and 3 are the common, and non-common is 7. I'll write all of the numbers first. Now the highest power we need to take, so 2 power 4, and the highest power we need to take for 3, that is 3, and 7 is a non-common factor, we'll take the power as is, right? Now let's multiply all these so that we'll get, here I want to add one point guys. See, first of all we'll write all the factors, then the common factors highest power we will write, then the non-common factor 7 power 1 as is we will take. Okay, so see here 2 3 are the common factors, so I took the highest power, so that is 4 and 3. 7 is a non-common factor, so I took power 1. Okay, so if you multiply all these three together, you will get 3024. Now let's do it for HCF. HCF means we need to consider only the common factors. The common factors are 2 as well as 3. So I'll write the factors first, 2 and 3. Then since we are doing for HCF, we need to take the least powers. Least power in 2 is 1 and least power in 3 is also 1. So 2 times 3 gonna be 6. So HCF we got 6. Next step is we need to multiply LCM and HCF. So I'm going to multiply 3024 times the HCF that we got 6. So I get 18,144. Now let's multiply the numbers, that is product of the numbers, that is 336 times 54. So if you multiply, you get the same number, 18,144. Hence it is verified. Next problem, this time we have 3 numbers, but no need to check LCM times HCF equal to product of the numbers. Why we will discuss later. First of all, we will find LCM and HCF. So we know 12 is an even number, it will be divisible by 2, so 2 times 6, and then 2 times 3. So 3 is a prime number, we'll stop here. Then 12 is a 2 square times 3 power 1. Now let's do it for 15. I think not required. So 15 is, we know 3 times 5 because both are prime numbers, so you can write power 1. Next 21 is also same, so 3 times 7, 3 power 1 and 7 power 1. Okay, now let's do for LCM first. LCM means we need to take the common factors and non-common factors all together. So I'll take all the numbers first. Okay, so here you can see the non-common factor is 2 and the common factors are 3 only, right? So I'll write first of all the factors that are 2, 3, 5 and 7 irrespective of their powers. Now LCM means we need to take the highest power. 2 is a non-common factor, so we'll take the power as is, 2 square, and then 3 is a common factor in all 3, so we'll take the highest power, so all of them having power 1, so no problem, 1 we will take. 5 and 7 are non-common, so all powers will take as is. Now let's multiply this so that we will get 420. So this is the LCM. Now let's do it for HCF. So before that, 2 squared is 4, right? 4 times 3 times 5 times 7, that is 420. Now let's do it for HCF. HCF means we need to consider only the common factor. So the common factor is 3 everywhere. See, 3 power 1 here, 3 power 1 here, 3 power 1 here. So all of them having the same power, so no issues. So 3 power the smallest. So the smallest is 1, right? So I'll take power 1, that is 3. Finally, the LCM is 420 and the HCF is 3. Let's do number 2 now. The second one is an interesting question because see the number 17, 23 and 29. So if you observe these numbers, these are prime numbers, correct? All these are prime numbers. So if you find all three prime numbers, then the LCM will be product of all the numbers because we don't have any common factors in that, right? So except one, we don't have any common factors. So LCM will be product of all three numbers, okay? And the HCF means highest common factor. Since they are all prime numbers, so the common factor will be 1, okay? Sometimes we should be very smart, right, while doing the sums. Hard work doesn't work sometimes, smart work will work. Okay, let's multiply 17 times 23 times 29, then you get 11,339, right? Let's do number 3. Observe the numbers again. The numbers are 8, 9 and 25. All these three are co-prime numbers, guys, okay? So first of all, let's prime factor, then we'll see. So 2 times 2 became 3 times, so 2 power 3. We know 9 is 3 squared and 25 is 5 squared, okay? Now see, is there any common factor in this? There is no common factor, okay? So even 8, 9, 25 are composite numbers, but there are no common factors in that. So all of them are co-primes. If you find co-primes, then we will do multiply same like prime numbers, okay? So since there are no common factors, what we do is we are going to multiply all the numbers to get the LCM. Remember, co-primes means no common factor, okay? So the HCF will be 1 because there is no common factor, and the LCM will be 8 times 9 times 25. If you do that, you get 1800, okay? This is the smartest way to do this problem. Let's quickly jump on number 4. It is given that HCF of 306 and 657 is 9, and you need to find the LCM of these two numbers. So we already proved that the numbers product is equal to the product of their LCM and HCF when two numbers are given. Remember, only two numbers, okay? So here the numbers are 306 and 657. HCF is given by 9. We have to find LCM, okay? So HCF times the LCM equals to the product of the numbers, right? This we have proved. This works when you have only two numbers, okay? The HCF is 9 times LCM we have to find, so I'll keep as is. Now the product of the numbers means we need to multiply 306 times 657. Now let's shift 9 to the opposite side, so it will divide, okay? But here see, 306 times 657, you no need to multiply. We can keep as is. So I will keep them as is, then divided by 9, okay? Since both the numbers are divisible by 9, so check the divisibility rule of 9, then you will understand why it is divisible by 9. So 9 times 1, and I am going to cancel 657. So 9 times 7 is 63 and 9 times 3 is 27. So it will be 73. Let's multiply 306 times 73. So that will be our LCM. If you multiply, you should get 22,338. This is the required LCM, okay? So let's jump another problem, number 5. This problem is an interesting one. See, 6 power n can end with the digit 0 for any natural number n or not. We need to check, okay? So to check this, you need to see my introduction video, guys. I have explained everything about prime factors. So if you missed the video, please watch that video first. Then this will be easy for you. Okay. So now let us discuss about divisibility rule of a number that is ending with 0. So any number ending with 0 must contain the prime factors 2 and 5. That is mandatory. Okay. So if any number is ending with 0 means it will have 2 and 5. We don't see how many times it is repeated, but at least once 2 and 5 must repeat. Okay. So now let's check for 6 power n. So we can write 6 as 2 times 3 and the power n. This if you distribute, then it will be 2 power n times 3 power n. Okay, now in the power of 2 power n, we have all the factors of 2 up to n times, right? Even if you take 3 power n, it must contain all 3's n times. So which one is missing, guys? We must have 2 and 5, right? So we got 2, but we are missing 5, right? So that means, will this end with 0? No, right? So 6 power n will not end with 0. Okay. Now let's get into number 6. Explain why 7 times 11 times 13 plus 13 and 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5 are composite numbers. See guys, any class you have studied from 6th, the chapter starts with the number theory, right? So in that we have learned about different types of numbers. Let me recall at this moment composite number and prime numbers. So let me take a number which is composite number. 6 is my composite number. Why? Because I can write 6 as 2 times 3. That means 2 and 3 are factors of 6. 2 and 3 divides 6 completely, right? So if I take prime numbers, suppose 7, so I can write 7 as product of 7 times 1. Do I have any other chance to write 7 as a product? No, right? I have one and only chance that I need to start with the given number and 1. So such numbers are said to be prime numbers. Prime number means what, guys? So a number is divisible by itself and 1 is always a prime number. Okay. And a number which can be divided by any other number other than 1 and itself is composite number. Now let's check. So it's given like 7 times 11 times 13 plus 13. Okay. So now no need to multiply here, like 7 times 11 times 13. We no need to multiply. So I'm not going to multiply that. So if you carefully observe, in the product we have 13 and plus 13. So 13 is common here. So according to distributive property, I will take 13 as a common. If you take 13 common, you have 7 times 11 plus 1. Okay, now let's multiply 11. 7 is 77 plus 1 times 13. So it is 78 times 13. So we have written here the number into 78 times 13. That means the given number is a composite number. Now let's check the second problem. That means 7 times 6 times 5 times 4 times 3 up to 1 plus 5. I think you got an idea, guys. Now what is common in these two? First we will check that. So 5 is a common in both, right? So again, according to distributive law, let's take 5 common. Okay. So 7 times 6, 5 is out. So 4, 3, 2, 1 plus we have taken 5 common, so we leave 1 here. That means it is also a composite number, right? So 5 times some number, that will give us a composite number. If I multiply, I'll get 168 and then plus 1 times 5, that is 169 times 5. So product of two different numbers will give us what? It's a composite number. Okay. Let's jump to next question. In this problem, see guys, it's a word problem. Let's read out the problem. Whenever the word problem is given, you must underline the numbers. Okay, so this is a good technique. So you need to underline the numbers, names, so that you can understand and you will not forget. Okay, so there is a circular path around a sports field. Sonia took 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and will go in the same direction. After how many minutes will they meet again at the starting point? Okay, let's take a circular path. Now see guys, there is a circular path. Now two people are here. One is Sonia and Ravi. Who is the slower? Sonia, because she took 18 minutes to complete the round, whereas Ravi is faster. He took only 12 minutes to complete the round. Okay, so after 12 minutes, Ravi will be at the starting point and Sonia will be completing her somewhere around 3/4 round, right? Now let us look at the definition of HCF first. HCF means highest common factor, right? So the common factor is always less than these two numbers. So the HCF will be less than 18 and 12. That's not what we want, right? So LCM is always bigger than these two numbers. Okay, so we need a number which is bigger than 18 and 12 minutes so that this Sonia and Ravi will meet after that particular number. Okay, that means we need to find the least number. Okay, after how many minutes they are going to meet it. Now let us see the LCM means. LCM is the least common multiple, right? So the multiple is always greater than the given two numbers. Okay, so here you see in this problem 18 and 12. So after one round they are not going to meet. That means if you consider 18 minutes, after 18 minutes they are not going to meet. That means we need a number which is more than 18 and 12. That means we have to find LCM. Okay, to find LCM we have two different methods. So let us do a simple method. I'll take 12 and 18 and these two numbers are even, so these two numbers are divisible by 2. So 2 6 and 2 9s. Then again these two are in 3 table, 3 2s and 3 3s. Now 2 and 3 are the prime numbers and they are not going to be in any table together. Okay, now let's write the product of all the numbers. So 2 times 3 times 2 times 3. Okay, our regular method 12 we can write as prime factors is 2 square times 3 and 18 2 times 3 square. To find LCM what we do is we are going to take the highest power in the common factors. Okay, common factors are 2 and 3. The highest power for these are 2. Okay, so 2 square times 3 square. Okay, so if you simplify and multiply this you get 36 as our LCM. That means after 36 minutes they are going to meet at the starting point. So after 36 minutes Sonia completes 2 rounds and Ravi will complete 3 rounds and they will meet again at the starting points. Hope you understand all the lecture. So please like and subscribe my channel. Let's meet in another video with another chapter. Until then, take care and bye.